Hello guys, welcome back to another question from the chapter integral functions, and let us see what do we have to integrate today. So we get a function as cos 2x divided by cos x plus sin x raised to the power 2. So how do we approach this problem? Let me show you how to do it. Cos 2x can be written as it is, and we simply open the denominator, that is a plus b raised to the power 2. So we get a square plus b square plus 2 sin ab. So cos square x plus sin square x will give me 1 plus 2 sin x cos x will give me sin 2x. Now you can see that our numerator is the exact differential of some part of the denominator. Let me call that some part of the denominator as d. Our whole denominator is d, and I am calling that some part of denominator as d, small d. So we can say let me call it x. So we can say that not x. I think the variables are very confusing. Let me call it a. That some part of denominator is a. So we can see that dA by dx is exactly equal to numerator. So this question becomes of substitution. Now let us see the solution, how they have done it. Okay, till here they have done the same thing that I showed you, cos 2x upon 1 plus sin 2x. Now they have assumed 1 plus sin 2x is equal to t. Now differentiating it on the both sides, we get 2 cos 2x dx is equal to dt. Now you can observe that we have cos 2x dx in the numerator, and that can be replaced by dt by 2, and our integration becomes easy. Now moving to the next slide. Okay, so we have cos 2x divided by cos x plus sin x raised to the power 2, as it can be written now as 1 upon 2 into integration of 1 by t dt. Now the integration is pretty easy, as we already know that integration of 1 by t is log modulus t. But before signing off with the final answer, we need to remember that t needs to be back substituted into the original variable, that is x. So what did we assume rt as? We assumed rt as 1 plus sin 2x. So that is it. That is our final answer. Our final answer is half of log of 1 plus sin 2x plus c, where c is an arbitrary constant. So that is it. I hope you all got it. Thank you. Have a nice day.